Hi everyone, so now we're going to be talking about terms and geometric sequences. In a previous video we talked about arithmetic sequences, and arithmetic sequences are when we're adding or subtracting every time. So in geometric sequences, instead of adding or subtracting every time, we're multiplying or dividing by something every time. So that's the big difference between arithmetic and geometric sequences. There's no other kind of sequences we're going to learn about, so those are the only two you'll have to remember. So when we talk about geometric sequences, the first thing we want to do is figure out what we're multiplying by every time. And that is called our common ratio. So we represent that with the letter R. We, instead of saying D for our common difference, like we did in arithmetic sequences, we would say R equals something for our common ratio. Okay. So the first two examples in this, for the self-check, we want to decide if the sequence is geometric, and then if it is, find its common ratio. So let's just get started with those. The first example is -2, -6, -18, -54, and so on. And so to decide if it's geometric, we're going to do something really similar to what we did with the arithmetic sequence. We're going to say, well, to get from -2 to -6, what did I have to multiply by? So in this case, I had to multiply by 3, because -2 times 3 is -6. Then to go from -6 to -18, what did I have to multiply by? Oh, I had to multiply by 3 as well. And then to go from -18 to -54, what did I have to multiply by? I had to multiply by 3. Now let me tell you this. If you couldn't figure this out, sometimes geometric sequences are a little bit harder to figure out than arithmetic sequences. So if you had a hard time figuring out what you were multiplying by every time, the easiest way to do this is to do the second number. Let me write this down. Second number divided by the first number, and that will give you your common ratio, okay? And if you wanted to double check that it was arithmetic, like what we're trying to do, you would do the second number divided by the first number, and you'd get an answer for our common ratio. Then you could do the third number divided by the second number, and if you get the same answer, then you know that you have the right common ratio, or the same common ratio, which means that it's geometric. You could continue to do it. You could do the fourth number divided by the third number, the fifth number divided by the fourth number, and just make sure that all of your answers are the same. But if you can figure it out without having to do the second number divided by the first number, that's totally cool too. So in this example, we know that we're multiplying by 3 every time, which means that it is geometric. So we're going to say geometric. And because it's geometric, we want to find our common ratio, or what we're multiplying by every time. Well, good news, we already found that. We know that it's multiplying by 3 every time, which means our common ratio is 3. Okay, let's look at the next example. So the next example is 2, -8, not negative, let me erase that so we don't get confused. 32, -128, and so on. So once again, we have to figure out if we're multiplying by the same thing every time. So to get from 2 to -8, the first thing I notice is I'm moving from a positive to a negative. When I'm moving from a positive to a negative, I have to be multiplying by a negative number, because we know that a negative times a positive is a negative. And then to go from 2 to 8, we multiply by 4. So this time we're multiplying by -4. Now let's make sure that if I go from -8 to 32, I'm also multiplying by -4. So again, we're switching from negative to positive, which means I have to multiply by a negative number. And to get from 8 to 32, once again, multiplying by 4. And same thing goes for here. So to go from 32 to 128, I know these numbers are getting a little bit bigger, but you could double check this in your calculator. So 32 times -4 is a -128, which means that we're multiplying by -4 every time, which means that this sequence is geometric. And our common ratio is -4, because we're multiplying by -4 each time. Now this sequence is kind of cool because it's flipping between positives and negatives. That only happens in geometric sequences, because when you're multiplying by a negative number, it'll flip between positive and negative. Okay, so that's how we decide if it's geometric and what the common ratio is. Now let's talk about how to find specific terms. So to find specific terms, we need, once again, there's 2 different ways that we can do this. The first way is potentially we could just continue the pattern on until we find the specific term that we're looking for, or we can use the formula. Now, I didn't write the formula down at the beginning, but I'm going to write the formula down here. It's a sub n is equal to a sub 1 times r to the power of n minus 1. Now, a sub n is considered the nth term. And that's usually the term we're looking for, okay? So in this example, for examples 3 and 4, we're going to try and find the 8th term. So in this case, our n would be 8. Or that's the term we're trying to find. Now, a sub 1 is considered our first term. And our first term is just the first term or number in the sequence. And then r is that common ratio, what we're multiplying or dividing by every time. And then n right here is that term number. So like in this case, because we're finding the 8th term, that n will be 8. Okay, so let's plug in what we know. Because we're trying to find the 8th term, I'm going to, oh, sorry. I said it, but I didn't do it. I'm going to replace the n with an 8. That tells me that I'm trying to find the 8th term. Then for my first term, oh, that's just the first number in the sequence, which is 1. Then I'm going to multiply that by r. Now, we don't have our r. Let's go back and kind of figure out what our r is. So to go from 1 to 5, what did I have to multiply by? Oh, I multiplied by 5. To go from 5 to 25, I multiplied by 5. To go from 25 to 125, I multiplied by 5. So our r has to be 5. I'm going to write that over here. R is equal to 5. And then that's to the power of n minus 1. Now, because we're finding the 8th term, our n is 8. So it's going to be 8 minus 1 up here. And then we plug that into a calculator, which would give me that the 8th term is equal to 78,125. So once again, you could potentially continue this pattern on until you have 8 numbers. And because 8 is a smaller number than like the 23 that we were doing for the arithmetic sequence, it might go a little bit faster if you did it that way. But I do want to give you the option of using this formula, just in case you're asked to give a bigger term number. Okay, let's go to that 4th example. So the 4th example is 3, -12, 48, and -192. And so the first thing I'm going to do, well, I'm going to write down the formula first, so that I remember everything that I need to have. Then I'm going to figure out my r. So what am I multiplying by every time? So to go from 3 to -12, because it's flipping between positive and negative, I know I'm going to multiply by a negative. And this is actually a -4, again, because to get from 3 to 12, I multiply by 4. Now, to get from -12 to a positive 48, once again, I know I'm multiplying by a negative. 12 to 48, 12 times 4 is 48, so I know it's multiplying by -4. And same thing over here, to get from 48 to -192, I multiply by -4. So that tells me that my r has to be equal to -4. So now I should have all of my information to plug into this formula. So a sub n, it's going to be a sub 8 because I'm trying to find the 8th term again. And then a sub 1 is my first term. In this case, that's just a 3. That's the first number in front. That's the first chunk of my sequence. Then it's multiplied by r. We just discovered that r was -4 to the power of n minus 1, but we know that n is 8 because we're trying to find the 8th term. So I'm going to replace that n with 8. So then I'm going to plug this into a calculator. And it's really important to have your r in parentheses, this thing. And I didn't say that in that last example, but just specifically for your calculator, it's really important to have that in parentheses, or else your calculator sometimes doesn't read it right. So make sure that you have it that way. When I plug that into a calculator, I'm going to have that the 8th term is equal to -49,152. So it just continues to get more and more and more negative. Or no, that's not even true, because it's flipping between positive and negative. We just happen to have a negative answer. And this is how we deal with geometric sequences.